All right, we're going to look at how to make solutions on a worksheet. So this is one of the worksheets we have for honors chemistry. And we're going to do 3 problems just to give you a start with each of the 3 formulas. So if you would have watched the presentation or you read and took notes, you know that there's 3 different formulas you need for making solutions. Part 1 says making solutions from a solid solute. So we have a formula for that, and that was the amount of solute you need, the number of grams, is equal to the molarity of the solution you're going to make times the volume of that solution that you're going to make times the molar mass in grams of that solute. So like all problems we do, it's really important to ID what you know and then what you're trying to find. So since it's saying how would you prepare, that's going to tell us we need to write in sentences when we're done with this problem. But since we're talking about from a solid solute, it means we need to find a number of grams of that solute. We're going to make a 250 milliliter solution. So this will end up being our volume. So that's going to be liters, but we need to make sure we change that to liters because that's the definition of molarity. It's telling us a 0.22 molar solution. And then since it's given us this formula, we can figure out the molar mass in grams. Now, like I was saying, you want to organize your work. So the volume of the solution that we're going to make, we need to measure it in liters, which means we need to move our decimal 3 spots left to go from milliliters to liters. So we're going to make a 0.250. There's another 0 there for sig figs. The molarity we know is 0.220. And then the molar mass in grams of sodium hydroxide, you would use your periodic table, 2299 plus 16 plus 1.01 gives you 40.0. That doesn't have sig figs on it. That's grams per mole. Now, we know we're going to use this equation right here. So G is equal to the molarity. Now, molarity is also known as moles per liter. So sometimes it's nice to write this as moles per liter as far as the unit goes. Times the volume, which is 0.25 liters, times the molar mass in grams, which was 40. Now, of course, you can get away without showing your units here, but I just want to show you that if we look at our units, liters are on the bottom and they're on the top, they cross off. Moles are on the top, they're on the bottom, they cross off. The only unit we have left is grams, and that's what we're solving for. So the number of grams that we get, if you plug this in your calculator, ends up being 2.20. I'm using 3 sig figs from this number right here. Leading zeros don't count. Zeros have to be to the right of a non-zero, and you have to have a visibly drawn decimal point for those non-sandwich zeros. So now that we know that this is the number of grams of sodium hydroxide we need, it says, how would you prepare? So we need to describe that. Our steps were half fill a volumetric flask with deionized or distilled water. Then here's where we need to be specific. Add 2.20 grams of sodium hydroxide. So this is what we just calculated. And dissolve. Number 3, fill to a final volume of whatever it says in your problem, to a final volume of 250 milliliters. And an even better answer would be half fill a 250 milliliter volumetric flask, being descriptive there. So that's how you would answer a problem like number 1. Problems 2 and 3 on this sheet are very similar. For part 2, I'd like to do question number 2. When you do question number 2, and all these questions actually, you're going to be using the formula M1V1 equals M2V2 because these are talking about stock solution. So how would you prepare 250 mils of a 3.5 molar sodium hydroxide solution? The solution you want to prepare, if you just always call that the second solution, so V2, M2, starting with a 1 liter stock bottle that's 6 molar. Now, I'm choosing this problem because this one happens to tell you how much you have of that stock, but we don't actually care about that number because we're going to look at how much of this 1 liter we need to use to make that solution. So this is M2, or excuse me, M1, excuse me. So we know V1 is our question mark, M1 is 6 molar, V2 is equal to 250 milliliters, and then M2 is equal to 3.50 moles. Now, technically to make units cross off, you should change this to liters, but because we have 2 volumes, as long as we keep them in the same unit, we would, well, basically our volume that we're solving for will end up being in milliliters because we're not going to switch our units. So we know we're using M1 V1 equals M2 V2. So if we just plug those numbers in, we have 6 times V1 equals 3.5 times 250. Of course, divide by 6, V1 equals that whole fraction, which ends up giving us a number of 146 milliliters, or 0.146 liters, whichever one you prefer. You're probably going to be measuring in milliliters. Again, you want to describe how you make this. So step number 1 is to half fill a 250 milliliter volumetric flask with DI water. Since we have 146 milliliters that we need to add, you probably don't want to half fill. You probably want to just do a little bit of water, but in general, we're just saying when we say half fill, we mean put some water in. You're not being specific. Number 2, add 146 milliliters, and I'm going to actually write down of what? Of 6 molar NaOH. Number 3, dilute to 250 milliliter volume. And you're done. Flipping to the back page, this is where you're using the final concentration, MF, is equal to M1 V1 plus M2 V2 over the V1 plus V2. So what's the final concentration? That's MF equals question mark. By mixing 150 milliliters, so there's our V1 of a 0.245, it's M1. We know that we have 300 milliliters, so that's V2. And M2 is equal to 0.15 molar. Then you just plug these numbers in. This one doesn't say how do you make this, so you're just going to solve MF equals M1 0.245 times 150. As long as you keep your volumes in the same unit, you're fine. 0.15 times 300. To keep everything orderly, throwing the whole thing in parentheses. And then the bottom, you need your volumes again, 150 plus 300, so a total of 450 milliliters. MF, if you solve for this, ends up being the number 0.182, and that's big M, because you're solving for molarity, and that's sodium hydroxide. This molarity should end up in between the two that you use in your math, so 0.245, 0.150, so that's in between, and then whichever you end up using more of, we use 300 milliliters, so this would have to be closer to the 1.15 than it would be the 0.245, because we used twice as much of this solution, and the 0.182 is definitely closer to 0.150. So again, part 3 is going to be just like this, just do the other 2 problems. Part 4, don't worry about that at this moment. Hope that helps. Do the best that you can, and you can always check your work. There is an answer key posted. Thanks.